All right, so the next problem we're doing now is problem 17 from chapter 1. Again, this is Classical Mechanics 3rd edition of Goldstein, Poole, and Sofco. And what this problem is asking us, I'll read the whole thing. It says a nucleus originally at rest decays radioactively by emitting an electron of momentum 1.73 million electron volts over C, and at right angles to the direction of the electron, a neutrino with momentum 1.00 million electron volt over C. And then it gives some conversion factors you can see here. In what direction does the nucleus recoil, it asks. And what is its momentum? And if in mega electron volts over C, and if the mass of the residual nucleus is 3.90 times 10 to the minus 25 kilograms, what's its kinetic energy in electron volts? Okay, so to start this thing off, it's actually pretty simple. So we're going to just do, we're going to have our y-axis and our x-axis just to draw it so that we can sort of make sense of it. And we have these two vectors. We have an electron going this way, and it has a momentum of, it has a momentum of 1.73 MeV over C. And then and this is x. Always label your axis. Okay, this is y. And then we have momentum of our neutrino, which I'll just call gamma or something. And then that is 1.00 MeV over C. Okay? So all we're really doing is understanding Newton's, the second law, which is for every action, there's an opposite and equal reaction. So our nucleus was at rest in our reference frame, let's just say, and then it's going to go in the opposite direction because the force is going to cause a recoil. So that's the big takeaway here, just understanding Newton's laws of motion. And so all we're doing is we're adding the momentum vectors of the electron and the neutrino, but we're changing direction. So it is minus PE minus PN, and that's all. And so we're just going to say minus 1.73 x hat minus 1.00 y hat. Okay, so that's all we got to do there. To find, so this is our vector, but we need to know the magnitude and direction, right? So the magnitude is just going to be our distance. It's going to be the distance here. And to calculate that distance, it's as simple as the square root of x squared plus y squared. It's that simple. So we have 1.73 squared plus 1 squared and the square root of that, and it turns out that it's about 2 MeV over C. Okay, so this is our answer for the momentum of the residual nucleus. So you put P underscore R. So that is our magnitude of this guy. Okay, so now we need to find out what direction it is. And so if we go back up to our graph, I'll kind of highlight it in green. It's this. If it were going this way, it really doesn't matter which way you choose because we're going to do the same operation. Then our x is going to be this electron, which is 1.73, and our y is going to be the neutrino, which is 1. And this is the angle we want to know. And then that is just the arctangent of 1 over 1.73, which turns out in degrees is about 30. And that's about it. It's that simple. And obviously you have to say in the opposite direction, right? The opposite. Because you got to know it's not going this way, it's going that way. So in the opposite direction. Great. So what else is it wanting us to do? It's wanting us to find out the momentum. We got that. So it's saying if the mass is 3.9 times 10 to the minus 25 kilograms, what is its kinetic energy in electron volts? So our kinetic energy, we all know and love, T equals P squared over 2N. And what I did is I used this, to make it simpler for me, I used CGS. You don't have to. There are other ways to do it. Oh, excuse me. There are other ways to do it, but I use CGS. So 1 MeV in CGS is equal to 5.33 times 10 to the minus 17 grams centimeter per second. It just makes it a little bit easier. So I just have this, and we have two of them, right? So that's 1.066 times 10 to the minus 16 grams centimeter per second. So this is our momentum in CGS. And we just need to square it. 1.066 times 10 to the minus 16 squared over 2 times our mass. And our mass was what? 3.90 times 10 to the minus 22 grams, because it needs to be in grams. And that number, when you punch that into the calculator, ends up being 1.4543 times 10 to the minus 11. And this is erg. And that's our CGS system. And now we're just going to put it back into electron volts. So 1.6021766 is 34 times 10 to the minus 12 ergs is equal to 1 electron volts. So we just do the conversion. So 1.4, so our T equals 1.4543 times 10 to the minus 11 over 1.6021, we'll just call it 8, times 10 to the minus 12. Punch this into a calculator and you're going to get about 9.08 EVs. And that is our final answer. Thanks.